Have you ever wondered how complex projects like a skyscraper construction are managed efficiently? This is where the concept of multiple successor logic comes into play, a cornerstone in the realm of project management. Multiple successor logic, as the name suggests, allows for an activity within a project to have more than just one successor activity. This implies that several actions can be set in motion concurrently once a particular task is completed. Imagine a relay race, where the baton isn't just passed to one runner but several, all racing towards different finish lines. The beauty of multiple successor logic lies in its capacity to streamline processes, enhance efficiency, and maintain a steady momentum in project progression. It's like having multiple roads leading out of an intersection, each one paving the way for a different part of the journey. Now, let's dive into a detailed example of a construction sequence with multiple successor logic. Imagine a construction project of a skyscraper. The project starts with the excavation of the site. This is the initial stage, where the ground is dug up to create a solid base for the towering structure. And this is where multiple successor logic comes into play. Excavation is a crucial part of any construction project. It lays the groundwork for everything that follows. But once the excavation is complete, there isn't just one task that follows. Instead, multiple tasks spring forth, all of which are successors to the excavation process. It's like a tree branching out, with the excavation as the trunk, and the successor activities as the branches. One of these successor tasks is laying the foundation. This is the part where concrete is poured and set, creating a stable base for the skyscraper. It's a massive job, one that requires careful planning and execution. But while it's important, it's not the only thing that needs to happen once excavation is done. Simultaneously, another successor to excavation is setting up the site office. This is where the project managers and other key personnel will operate from. It's their hub, their base of operations. It's where the blueprints are studied, where meetings are held, where decisions are made. It's an essential part of the construction process, and it can happen concurrently with the foundation laying. And then there's the arranging of utilities. This includes setting up temporary electricity for the site, arranging for water supply, and ensuring there's a proper waste management system in place. This is another successor activity to excavation, and it too can happen at the same time as the other tasks. This is the beauty of multiple successor logic. It allows for multiple tasks, all successors to a single predecessor, to occur concurrently. It's a way of maximizing efficiency and productivity. Instead of waiting for one task to finish before the next one starts, multiple tasks can happen at the same time. It's like a well-orchestrated symphony, with each instrument playing its part in harmony with the others. In the case of our skyscraper construction project, it means that as soon as excavation is done, several tasks can kick off. The foundation can be laid, the site office can be set up, and the utilities can be arranged. Each of these tasks is a successor to the excavation, and each can happen concurrently with the others. This is how complex projects like skyscraper construction are managed. With multiple successor logic, project managers can ensure that the work flows smoothly, that no time is wasted, and that the project stays on track. As the initial stage concludes, the project moves to the next phase, further demonstrating the use of multiple successor logic. It's a dynamic, efficient way of managing projects, and it's a key part of how skyscrapers and other complex structures are built. With the foundation laid, the site office set up, and utilities arranged, the construction progresses to erecting the building structure. It's here that our multiple successor logic comes into play, allowing us to manage several concurrent activities with precision and efficiency. Let's take a moment to consider what's happening on our construction site. We're not just building walls and floors, we're also installing elevator shafts and setting up internal utilities. Each of these activities is a successor to laying the foundation, setting up the site office, and arranging utilities. And yet they're all happening at the same time. This is the essence of multiple successor logic. The construction of the building structure can't wait for the elevator shafts to be finished, nor can the setting up of internal utilities wait for the building structure to be completed. These activities must run concurrently to ensure the project stays on schedule. The key is to manage these activities in a way that they don't interfere with each other, and that's where our multiple successor logic comes in. This logic allows us to keep track of all these activities and manage them effectively. We can see at a glance which tasks are dependent on each other and which can be carried out independently. This helps us avoid bottlenecks and keep the project moving forward. Let's consider an example. The construction of the building structure is a vast task, involving many different activities. Some of these, like framing and pouring concrete, can be done concurrently. Others, like installing windows and doors, must wait until the framing is complete. By using multiple successor logic, we can ensure that all these activities are scheduled in the most efficient way possible. Similarly, the installation of the elevator shafts and the setting up of internal utilities are both complex tasks, with many interdependent activities. Again, multiple successor logic helps us manage these activities effectively, ensuring that each is completed in the right order and at the right time. As we move into the final stages of construction, we continue to use multiple successor logic. The finishing touches, like painting and landscaping, are all successor activities to the main construction. Yet they too must be managed concurrently to ensure the project is completed on time and within budget. In essence, multiple successor logic is a powerful tool that allows us to manage complex projects with many concurrent activities. It helps us keep track of everything that's going on and ensure that all activities are carried out in the most efficient way possible. It's an essential part of any project manager's toolkit. As the project nears completion, the final steps also follow the multiple successor logic. The finishing touches are added, the site is cleaned up, and the building is ready for occupancy. And throughout it all, multiple successor logic has kept us on track, ensuring that every activity has been carried out in the right order, at the right time, and with maximum efficiency. With the building structure in place and utilities installed, the project moves to the final phase. The culmination of this intricate dance of construction is upon us, and it's where all the pieces come together in a symphony of final touches. Let's talk about the interior finishing. This involves a range of tasks from painting walls and installing flooring, to mounting fixtures and setting up the HVAC system. Each of these jobs is critical to the overall project, yet they are quite independent of each other. This is where multiple successor logic comes into play yet again. Each task can be performed concurrently, allowing for a seamless flow of work that maximizes efficiency and saves time. Simultaneously, the exterior landscaping is taking shape. Trees are being planted, pathways are being laid, and the parking lot is being paved. These activities too are managed using multiple successor logic. While the trees are being planted, the pathways can be laid out. While the pathways are being worked on, the parking lot can be paved. This way, each task progresses without waiting for the other to finish, creating a harmonious flow of work. At the same time, safety inspections are being conducted. These inspections ensure that all construction standards have been met and that the building is safe for occupation. They too are a series of tasks that can be carried out concurrently. For example, while the electrical system is being inspected, the structural integrity of the building can be checked. Again, this is an application of multiple successor logic. As you can see, the final phase of construction is a convergence of multiple activities, each important in its own right. But by applying multiple successor logic, these tasks are managed concurrently, ensuring that no time is wasted and that each task is completed efficiently. And there you have it, a skyscraper built efficiently using multiple successor logic. So, what does this all mean for project managers and teams? Let's break it down. Multiple successor logic is not just a fancy term, it's a powerful tool. It allows for the representation of concurrent activity logic and goes a step further by illustrating activities in a network that have more than one successor activity. Think about it. In the world of project management, rarely do tasks exist in isolation. More often than not, they're interconnected, influencing and affecting one another. This is where multiple successor logic comes into play. It offers a clear, visual representation of these connections, enabling project managers to plan, schedule, and allocate resources more efficiently. This logic also provides flexibility. In a dynamic project environment, changes are the only constant. Multiple successor logic allows for these changes and adjustments, ensuring that your project runs smoothly, regardless of the challenges that may arise. Remember, with multiple successor logic, managing large projects becomes a breeze.